Hello everyone, hello grade 12. Welcome to our second lesson with sequences series. Hello. Okay, so now we're gonna start with series and sigma notation. Remember, on our previous lesson we learned about the general form, which is I hope my screen is visible. So on our previous lesson we learned about the general term. The general term is the general term is Tn. Tn is equals to A plus open brackets n plus n minus 1 into d. So on our previous lesson we learned about Tn, that is the general term, is equals to A plus n minus 1 into d. So now we are going to learn about series and sigma notation. So what is the difference between a sequence? What is the difference between a series? And how can you how can you write series as a sigma notation? So we're going to learn about that just now. All right. So let's say we have this sequence. The sequence is 5 is to 7 is to 9 is to 11, and it continues, right? So this is a sequence. Now sequence, this is a sequence. So now let's write a series of the same sequence. So we would say 5 plus 7 plus 9 plus 11 plus, the series continues. So this one is a series. So this one is a series. Then now let's say you want to represent this in sigma notation. All right? So remember, we have A. So we have A, all right, I hope I'm being heard. So if you can't hear me, just comment so that I know that we're on the same page. Or if you are online, you can just comment. Okay, let me share our YouTube link. Just give me a moment. I just want to share the link. All right. So now we can continue. Okay, so remember, okay, previously we learned about Tn is equals to, that is the general term, is equals to A plus open brackets n minus 1 to D. So now the sequence, let's say we have this sequence, 5 is to 7 is to 9 is to 11, and also we have this series 5 plus 7 plus 9 plus 11. Remember, when we talk about series, we talk about addition, the sum. We're adding the sum of the terms. We're adding the sums of the terms. You see, these are the same terms. So when we talk about series, we're adding the sums of the sum, not the sums, the sum of the terms. So that's why we have a plus. That's why we have a plus. So this series continues. All right. Now, let's say we have this. Now I'm gonna write a sigma notation. All right. Okay, let's say we have this sigma notation. Here we have 4. Here we have 3n minus 2. Then here we have n is equals to 1. So what is the meaning of this? So this means that the terms will be 4. We will have 4 terms. We'll have 4 terms, right? So this will be the first number to substitute, and this will be the last number to substitute. So which means we have 5 terms. Yes, we have 4 terms. So this is the first number to substitute, and this will be the last number to substitute. So now let's write this in. Let's get the sum of the terms. How can we get the sum of the terms? So what we need to do here, we're going to say open square brackets. So we have 3 into the value of n. What is the first value of n? The first value of n is 1. In other words, in this case, we're putting 1. So it is not always 1. It can be any natural number. It can be 2, it can be 3, it can be 4, it can be 5. It does not mean it's always 1. This is just an example. So here we first substitute 1, then minus 2, close brackets, right, plus, we're evaluating this, we want the sum of this, plus 3 square brackets, 3 into, now we substitute, instead of 1, the value of n, we put 2, minus 2, square brackets, plus, open square brackets, 3 into 3 minus 2, close square brackets, plus, open square brackets, into 3 multiplied by the last number, which is 4. The number at the top represents the last term of this sigma notation, and the n in the bottom, remember, is not necessarily n. It can be I, it can be k, it can be any variable. So in this case we're using n, right? Then minus 2 close brackets. So what will be the sum of these terms? So here we'll have from here we will have 3 multiplied by 1, that is 3. 3 minus 2 we have 1 plus, then from here it's gonna be 6 minus 2, which is 4, plus, then the third term is going to be 9 minus 2, which is 7. Then the last term is going to be 12 minus 2, which is 10. So here we'll have 1 plus 4, that is 5. 5 plus 7, that is 12. 12 plus 10, that is 22. So our sum will be 22 is equals to 22. So here we are evaluating, we wanted the sum. What will the sum of this? So the sum will be 22. So this symbol represents sigma. This symbol represents sigma. Then this number that is on top of the sigma sign represent the last term of this sigma notation. Then this n at the bottom represent the first term to be substituted. The first term to be substituted where there is n. Right? So now let's evaluate another problem. Here we have, so let's evaluate another problem. Here we have, let's write the sigma notation. All right. Here we have 6. Then n is equals to 1. N is equals to 1, which means the first number we will substitute is 1. Then, I hope I'm being heard. Then 2n plus 3, right? So what does this mean? This means that the first 6 terms must be added together. So this means that the first 6 terms must be added together. The first 6 terms must be added together. That's what this means. So it means that the first 6 terms must be added together. So here you will say, so you're going to say, just we apply the same principles. So remember, here we had 4 as the last term to be added. Then here we have as the last term to be substituted, 4 as the last term to be substituted, and 1 as the first term to be substituted. And this implies that we only have 4 terms. We only have 4 terms. This implies that we only have 6 terms in this sigma notation. So this implies that the first 6 terms must be added together. We must add the first 6 terms to get the sum of this sigma notation. So how? So firstly, we're going to substitute 1. So we're going to say open square brackets 2 into 1. In this case, we're substituting 1 because it says that n, the number of terms, start with 1. Start with 1. So in this case, substitute 1 minus, 1 plus 3, right? Close brackets, plus, open brackets, 2 into 2. Remember the next number after 1 is 2, plus 3, close brackets, plus, open brackets again, 2 into 3, plus 3, close brackets, plus, open brackets, 2 into the next one is going to be 4, close brackets, plus 3, close brackets, plus, open bracket, 2 into 5, plus 3, close brackets, plus, open square brackets, 2 into the last term to be added. The last term to be added is, the last number to be substituted is 6 in terms of n. It's going to be 6. How or why? Because we have been told that the last, we'll have 6 terms here. We're going to have 6 terms. So the last number to be substituted should be 6. That's why we have 6 here. Plus 3, close brackets. All right. Now let's simplify. All right, so let's simplify. So here we'll have, all right, let's do this by inspection. We're gonna do this by inspection. All right, so we have 2 times 1, that is 2. 2 plus 3, that will be 5. Here we have 5 plus 2 times 2, it's 4. 4 plus 3, that will be 7. 7 plus 2 times 3 is 6, plus 3 is 9. So our third term will be 9 plus 2 times 4, that is 8. 8 plus 3 is 11. Plus 2 times 5 is 10. 10 plus 3 is 13. 13. All right. Plus 2 times 6 is 12. 12 plus 3, that is 15. All right, now let's get the sum. Let's get the sum. Remember, this notation means that the first 6 terms must be added together. The first 6 terms must be added together. So how do we get the first 6 terms? So we substitute with the first term to be substituted is 1 that is at the bottom of the sign of the sigma notation. This one is the first number to be added. Is not always 1. I have to stress that is not always 1. It can be any number. It can be 2, can be 5, can be 10, can be 6. It's not always 1. In this case, we're substituting, we're starting with 1. Right? And this one, it does not end at 6. It can be a number, it can end to 1,000. There are no limitations. So here we have 5 plus 7, that is 12. 12 plus 9, that is 21. That is 21. Then 21 plus 11, that is 33. 33 plus 13, that is 45. 45 plus 15, that will be 60. So here the answer will be 60. All right, now let's try and evaluate the second. Okay, let me give you a problem, a homework, not a homework, a classwork. All right, I'm gonna give you this one. So let me have a sigma notation. All right, so here we'll have 5. Here we have 2n plus 3, right? Then here we have n is equals to 3. So evaluate this sigma notation. I'm giving you 2 minutes. I'm giving you 2 minutes. All right, 1 minute 30 seconds remaining. One minute remaining. Thirty seconds remaining. Fifteen seconds remaining. All right, time's up. So here, remember, as I've told you before, that the number on top of the sigma notation, on top of the sigma notation, that is 5, it means that we're going to add 5 terms. I mean, it's going to be the last number to be substituted. It's going to be the last number to be substituted. The number on top of the sigma sign is going to be the last number to be substituted. Then n is equals to 3 is going to be the first number to be substituted. So which means our terms will end at 5, the last number to be substituted. So here we'll have square brackets, is equals to square brackets 2 into the first number to substitute is 3 plus 3, right? Close brackets plus open brackets 2 into 4 plus 3, close brackets, then 2 into 5, which is the last number to be substituted. So 5 is the last number to be substituted, plus 3, close brackets. Okay, even this one we're gonna do it by inspection because this is just simply, there's not much, so it's gonna be here 3 more 2 times 3, that is 6. 6 plus 3, that is 9. Then the next term is gonna be 2 times 4, that is 8. 8 plus 3, 11. Then the last one will be 2 times 5, that is 10. 10 plus 13, 10 plus 3, that is 13. That is 13, right? So here we'll have 9 plus 11, that is 20. 20 plus 13, the answer will be 33. So the answer will be 33. So I hope you are following. So this means that only the third, fourth, and fifth terms must be added together. Only the third, fourth, and fifth terms must be added together, right? So now let's do this example. I'm gonna give you a task. So here we have express the following series in sigma notation. Express the following series in sigma notation. Remember, when talk about series, the difference between series and a sequence, series we add them. So it's gonna be, here we have 3 plus 7 plus 11 plus, it continues, then plus 83. All right, so now express this series in sigma notation. Where would you start? So we have this series. It's a series because of the plus sign, because separated by a plus sign. It becomes a sequence if we put semicolon. That's when it becomes a sequence. But now it's a series because of the plus sign. Good. So now express this in sigma notation. How? So if you can notice, this is an arithmetic sequence. This is an arithmetic sequence. So we have the value of a. All right. So this is an arithmetic sequence. We have the value of a. What is the value of a? A is always the first term. In this case, our first term is 3. Then what is the value of d? The value of d is equal to successive term minus previous term. So d is equals to 11 minus 7, which is equals to 4. Or d is equals to 7 minus 3, which is equals to 4. Remember, common difference is always successive term minus previous term. All right, now remember our general term Tn. Remember the formula for our general term. Tn, right? What is a formula for general term? Tn is equals to A plus open brackets n minus 1 into D. We have the value of A and we have the value of D. Now let's substitute. So we have here the value of A is 3. 3, okay, is equals to 3 plus open brackets n minus 1 into the value of D is 4. So now let's simplify. Is equals to 3 plus 4n minus 4. So 3 plus 4n minus 4. Then let's simplify. Is equals to 4n, right, minus 1. So now Tn is equals to 4n minus 1, right? Remember here, Tn in this case, Tn, what is the value of Tn? Tn is equals to 83. Tn is equals to 83, right? So now we have here 83 is equals to 4n minus 1. Now let's solve for n. Then 84 is equals to 4n. Do you agree? 84 is equals to 4n. So remember, when we transpose here negative 1. We transpose negative 1 and it became positive 1. Then that was 83 plus 1, which is equals to 84. So now solve for n. Therefore n is equals to 21. So the value of n is 21. So here now we have the value of n, which is 21. So now let's write this in sigma notation. Let's write this in sigma notation. So here we have alright, so here we have the value of Tn. What is our value of Tn? Tn is 4n minus 1. So the value of Tn is 4n minus 1, right? So now here we're going to put 4n minus 1. Here we're going to put 4n minus 1, right? Then now, how many number of terms do we have? How many number of terms do we have? We have 21. So here we have 21, right? Then n starts from 1. In this case, n starts from 1. So n is equals to 1. All right. Let's prove if we are correct. Let's substitute 1 here. So if you substitute 1 here, it's gonna be 4 multiplied by 1, which is equals to 4. Then 4 minus 1 is 3. What was our first term? Our first term was 3. Our first term was 3. Then we had 7, 11. So I want the number we need to substitute starting with 1. I hope you are following. So we have wrote this series, this series into sigma notation. We have wrote this series into sigma notation. So I'm gonna give you a classwork just to test your knowledge, to test your skills. Now I'm gonna give a classwork. So here given all right, so here given the arithmetic given the arithmetic sequence, 7 is to 2 is to negative 3. Then it continues, right? Why do we say this is a sequence? Because there is no plus sign. If it was a series, we're going to have a plus here and a plus there if it was a series. But now as a sequence, we have a semicolon, right? So now one, two, three continues. Now calculate the sum of the first 18 terms given the arithmetic sequence 7 is to 2 is to negative 3. Calculate the sum of the first 18 terms. So I'm giving you 3 minutes to calculate the sum of the first 18 terms. All right, so let's go. Two minutes 30 seconds remaining. Two minutes remaining. All right, 2 minutes remaining. Given the arithmetic sequence 7 is to 2 is to negative 3, calculate the sum of the first 18 terms. All right, time up. So here, okay, the question says calculate the arithmetic sequence. Given the arithmetic sequence 7 is to 2 is to negative 3, calculate the sum of the first 18 terms. Remember, based on our previous examples, we can do that by substituting, right? But now, since 18, because if we're going to substitute 18 terms, it's going to take more time. So what can we do? Here we would say, so this is an arithmetic sequence. Remember, for an arithmetic sequence, we have A as the first term and the common difference, which is D. So we have the value of A is equals to 7, right? Then D is equals to successive term minus previous term. So in this case is 2 minus 7, which is equals to negative 5. Negative 5. So that is the value of D. All right. Remember, now if we're gonna use like let's go up. If we're gonna use something like this, it will take forever. The reason we use this method is because we were going to add up to 6 terms, from 1 to 6 terms. So it's easy. But now if we're adding up to 1000 terms, are you going to say you're going to write these up to 1000? So which means your paper will be full. So now we have a formula. We have a formula for calculating the sum of the sequence. We have a formula, all right. So here we have Sn is equals to n over 2 is equals to n over 2 is equals to n over 2, right? N over 2 into n over 2 into 2a plus open brackets n minus 1 into d, n minus 1 into d. All right, so this is the formula that we have. So remember, the reason we didn't use this formula because the number of terms were few. They were few. Now, since we're dealing with this one, which says that you must calculate up to 18 terms, we can't write that same procedure up to 18 terms because it's going to consume a lot of space and they're going to consume a lot of time. So this is the formula that we use, right? So now let's substitute our values. Here we have is going to be n over 2. Remember, let me write it down. N is equals to 18. So here we got is equals to 18 divided by 2. Then we have 2 into, what is the value of a? The value of a is 7, close brackets, plus, open brackets, what is the value of n? The value of n is 18. So here we'll have 17, right, multiplied by -5. So here we're gonna have 17 into -5, right? Then close brackets. Then now you just press with your calculator. So it's gonna be 9 into, 14 minus 17 multiplied by 5. So it's gonna be 14 minus 17 multiplied by 5, right? So you just use your calculator and get the correct answer. Perfect. Now I'm gonna give you another problem. Here we have sigma notation. So here we have 3n plus 4, then there we have 27 up to 27 terms, and the n is equals to 1. So I'm giving you 4 minutes to solve this one. Remember, in this one, you cannot write up to 27 terms in a paper. It's going to consume a lot of time. So that's why we have this formula. So I'm giving you 5 minutes to solve this. Your time starts now. All right, time's up. Okay, so here calculate the value of wave sigma. So the last term is 27, right? And the first to be substituted is 1. So here, now let's calculate the first 3 terms. So remember, if you want to calculate the first 3 terms, you just substitute n in this equation, in this expression. So we say a is equals to 3 into 1 plus 4. A is equal to 3 into 1 plus 4, then A is equals to 7. Then T2, excuse me, T2 is equals to 3 into 2 plus 4, which is equals to 3 times 2, that is 6. 6 plus 4, that is 10. Then T3 is equals to 3 into 3 plus 4, 9 plus 4, that is 13. Then common difference D is equals to successive term minus previous term. So is equals to 13 minus 10 or is equals to 10 minus 7, which is equals to 3. So common difference is 3. So now remember, we have this formula. Now let's substitute. Remember, we're calculating the value of this sigma notation. So let's substitute.